See one question, listen here. Prove that the nuclear density is independent of mass number. Nuclear density is independent of mass number. Or sometimes question will be, you find prove that nuclear density is constant for all the nuclei. Nuclear density is constant for all the nuclei. Or prove that the nuclear density is independent of mass number. Yes or no? Density does not depend. Radius depends. Density does not depend. Now see how to prove this. Proof you write. All of you listen carefully. Density. If I am telling density of the nucleus, what will write tell? Density of any substance. What you write? I am writing here density of nucleus. What will write tell? What is the formula of density? Mass of nucleus by volume of nucleus. This idea should be clear because density is mass by volume. Density equal to mass by volume. This one you know already, right? So mass of nucleus. Mass of nucleus. Now what we'll do here? Now density is rho, and mass of nucleus. Let's me take m. Volume. Let's take me v. Yes or no? Now all of you listen carefully. Rho density equal to what is the mass of nucleus? Now mass of nucleus is nothing but how many number of nucleons are there? Number of nucleons in the nucleus, neutron and proton. Number of nucleons means that is mass number. Mass number into mass of each nucleon. Mass of each nucleon. That means what I'll tell here. Now you consider actually neutron and proton mass is not same, but you here consider it is nearly equal. Okay, you consider, but not same. Exactly, it is not same. Neutron is heavier than what? Proton. So what you consider? You consider mass of proton into nuclear number. That is basically mass number. Mass of proton into mass number is giving you total mass of the nucleus. Okay, this idea I considered here. But remember, here neutrons also there, but a neutron mass, proton mass I considered here little nearly equal. But that is not exactly equal. That is what happening there. A nuclear mass, neutron mass is slightly greater than proton mass. But I considered near here. Then after I took mass of each nucleon is mp, mass of each nucleon mp, and what it is here taken? Now mass number means number of nucleons. So the total things will give you. What? Now mass of nucleus. So now what will do? Volume of nucleus. What is volume of nucleus? That is 4 by 3 pi r cube. What is the volume of nucleus? 4 by 3 pi. What is r? R is what? Radius of the nucleus. Now just before we understood that radius of the nucleus is what? R naught into a to the power 1 by 3. Yes or no? So now what we'll do? So we'll substitute that. So what is coming here? Now density equal to mass of proton into mass number divided by 4 by 3 pi r naught. Listen, r naught a to the power 1 by 3 whole cube. Now tell here, mass of proton into mass number. What will get? Say 3 4 pi r naught q into a. Into what? A. Are you getting now how a coming? How a is coming? Say a to the power 1 by 3 into 3. A to the power 1 by 3 into 3. Now 3 will cancel. So what will get here? 3 mp into a divided by 4 pi r naught q into a. Now a will get cancelled. Now what is density? 3 into mass of proton into 4 by r naught cube. Now your density of the nucleus. What it is? Density of the nucleus. Now see in the density expression, do you have any A? Do you have any A? No, right? That means mass number not present. That means from this expression what you understood? Now density of nucleus. The density of nucleus is independent of what? The density of nucleus is independent of, very good, is independent of mass of nuclei, mass number, independent of mass number A, mass number. Okay, so the density of nucleus is independent of mass number A. Clear? So see here in density expression there is no what? No expression of mass number. Okay, mass number is not coming. Okay, now here what you can do, if you calculate this all constants, 3 mp 4 pi r0 q, all value constant value actually. R0 is 1.2 for me, right? You know, you substitute here. Now you can write here r equal to nothing but what it is, r0 a to the power 1 by 3. I have substituted here this one. Okay, r equal to what? R0 a to the power 1 by 3, a to the power 1 by 3, a to the power 1 by 3 I have substituted here. So if q will take night, r0 q a to the power 1 by 3 into 3, 3 getting cancelled. So it is becoming a by a. So a by a also cancels. Okay, clear idea? If all the values will substitute, I will get this density in the order of 10 to the power 17. How much order? 10 to the power 17. That means for all the most of the nucleus, what will happen? Density is same, constant. Okay, that means for two nuclei, I am asking what is the density ratio? Rho 1 is to rho 2. What will come? Say 1 is to 1. Because for all the nuclei, what is happening? Density is coming what? Constant. So density ratio for any two nuclei. Suppose I am telling any two nuclei you tell. So suppose 2He4, one is aluminum 27. Okay, like this one you are taking. Yes or no? Two nucleus you two. Then here, what is the density ratio? Density ratio same. But radius ratio different. But density ratio same. Because radius depends on mass number. Or both are different mass number. So they will have different what? Radius ratio. But the density ratio for both will be same. Density ratio 1 is to 1. Did you understand or not? So that means what you understood? Density of nucleus is constant. It is order is 10 to the power how much? 10 to the power. This order if you will calculate, it will be 10 to the power 17 kg per meter cubic. Kg per meter. Yes or no? In this order it will come. Constant. So density ratio for any two nuclei if you take, then it is 1 is to 1. Now understood everyone? The density of nucleus is independent of a mass number. Clear idea? Yes? No doubt here? Okay. Thank you.